I was thinking about levers one day and I realized they're interesting and a little bit ironic because they're so simple and almost everybody knows how to use one, but almost nobody could describe or explain why they work the way that they do. Meaning that most people could tell you that if you apply a small force at the long end of the lever, then you will get a large force at the short end of the lever, but most people could not explain why that happens. I think most people just know that it happens, but they don't know why. And even in a physics class, you'll learn the math formulas to calculate the numbers involved. But from my experience, physics classes also do not give an intuitive approach to this or explain why they work the way that they do. From my experience, physics classes also teach pulleys the same way. You learn the math and the formulas and the numbers involved, but I've never actually seen an intuitive approach. So you can see my pulleys video if you want an intuitive approach on that. And for this video, I will show an intuitive approach on levers. We have a lever right here. There's a guy pushing down on the long end of the lever. I wrote F sub P for the force of the person. And then for the fulcrum and the counterweight, I made both of those anvils just for illustrative purposes because anvils are both very heavy and very tough, meaning that it takes a lot of force to crush them. So here we have anvil B. I just made a little triangle here so that way all of that force could be focused on one point on the lever. So the fulcrum will be anvil B, and then anvil A is the weight on the opposite end of the lever. So we have force F sub B, which is force of B pushing up, force of A pushing down, force of the person pushing down. To get an intuitive understanding about how levers work without even understanding any of the math, you can just turn the lever upside down. And so what we did here is turned a type 1 lever into a type 2 lever, which is how a wheelbarrow works. You can see here we have the person right here pushing up, anvil A is pushing up, and then anvil B becomes a slider weight, like those sliding counterweights used in bathroom scales when you stand on the scale and you slide that little weight back and forth. Now you can see that the closer to point A, the weight is of B. So as B slides over and gets closer to A, then that means A will support more of the weight, the person will support less of the weight. Or you could think of this as two people carrying a board with a weight on top of that board. The closer that the board is to person A, then the more weight person A will have to support. And thus, the person over here, the force of this person, F sub P, they only need to apply a very small amount of force in order to move the weight of anvil B. So this person right here only needs to apply a very small amount of force to move anvil B, while anvil A is providing a large amount of force. And that's it for just an intuitive feel of how levers work. Keep watching if you want to see an intuitive way to explain the math. Let's say that whatever force the anvil A is pushing up, we want the person to push up 1/4 of that. So we take the force of the anvil that's pushing up, multiply it by 1/4, and now we'll have the force of the person pushing up. Thus, we will have a mechanical advantage of 4-to-1. So you can say force of the person equals 1/4 of the force of the anvil. Multiply both sides of your equation by 4, and you get 4 times the force of the person equals the force of the anvil. So whatever force the person pushes up, multiply it by 4, and that's how much force the anvil is pushing up. Force of the person plus force of the anvil equals 100%. Because we only have two objects or two things here pushing up on the anvil B right here. So since force of the person plus force of the anvil equals 100%, I take force of the person, move it over to here. I take force of the anvil, that will equal 4 times the force of the person. So instead of F sub A, I write 4 times F sub P, and that will equal 100%. So F sub P plus 4 times F sub P equals 100%. So F sub P plus 4 times F sub P equals 5 times F sub P equals 100%. F sub P equals 20%. So since F sub P right here equals 20%, 20% times 4 equals 80%, and that will be the force of anvil A. So force of anvil A is 80%. We just make our same lever right here. Anvil A is pushing up on the 100 mark, that's 100%. And then we just create a slider weight. So anvil B will be the slider weight, meaning it can slide back and forth. That's why I have those little arrows right there. So we have 100%, 80%, 60, 40, 20, 0%. If anvil B is sitting right on top of anvil A, then anvil A will support 100% of anvil B. But that means that the anvil B will be sitting on top of the fulcrum, so that means the person cannot move it or elevate that weight. If we put anvil B right here at the 80% mark, then that means anvil A is supporting 80% of anvil B. The force of the person will be only 20% then. Mechanical advantage equals your force out divided by force in, so that's 4-to-1 mechanical advantage. This is also related to distance. Distance in divided by distance out, that'll also be 4-to-1. So this means that anvil A will be 1 unit away from the mass on top of the board, and then the person will be 4 times greater that distance. And next page. Here's how it is taught in physics class. Let's take the sum of our torques about point B, that has to equal 0. I'll use this bottom lever here for the example, but you could use either lever. So B right here will be the fulcrum, we'll say. Anvil A will be pushing up in a clockwise manner, so I'll make the clockwise twisting negative. So A will apply a negative force, and then the person here will push up in a counterclockwise rotation, so I'll make the force of the person positive. So sum of the torques about point B equals 0. That's torque of A plus torque of the person. Torque is the same thing as force times distance. Force of A, anvil A, will be 4 times greater than the person, as we just determined right here. So that's -4 times distance of A plus 1 times distance of the person. 4 times distance of A equals distance of person. 4 equals distance of person over distance of A. Therefore, that shows that the distance of the person must be 4 times greater than the distance of the anvil, or anvil A. And again, that's just what we showed right here. The anvil A is 20 units away from anvil B, the force that's pushing down. The person will be 4 times greater that distance, so the person will be 80 units away from that force. And 80 is 4 times greater than 20. And this is also an intuitive explanation as to how gears work, because gears are just spinning levers, or levers arranged in a circular pattern or in a spoke pattern. And I have a compound gear here with a small gear on the inside and the large gear on the outside. So this just makes a lever with a long end and a short end.